All right, so today we're going to talk about multiplying, dividing, and one of the really cool strategies for multiplication is called cancellation. And hopefully by the time we finish talking about cancellation, you'll be singing "Cancellation is my friend." Okay? So let's talk about what cancellation, multiplying, and dividing fractions is all about. And then I want you to learn how to do it and to practice today. Now this is what cancellation is. Cancellation is the process of reducing fractions. Remember yesterday we talked about reducing fractions using the same factor for both the numerator and the denominator? Well, when you cancel, you do that quickly and it makes your numbers more manageable when you're multiplying. Now this is a technique for multiplication. Even though we will use it when we're dividing because we do multiply, this technique is used when we are multiplying. And I want you guys to actually start singing "Cancellation is my friend." It makes your numbers smaller so that you'll be able to handle them. Now this is the process. You take one top number, which is your numerator, and one bottom number, which is your denominator, reduce them by the same factor. Now when we reduce, we have to divide, and we divide completely where there's nothing left over. And that's the same as saying that we factor them evenly. Now after we have divided, you keep dividing until you can no longer divide. Now yesterday I gave you a big clue or a big strategy to stop yourself in your reducing. What was that little phrase I told you guys? When I only have the factor of 1 that goes into both the top and the bottom, I'm done. That's how you guys know you're finished. So you keep that strategy in mind. So I have two numbers here, two fractions here, 4 thirds and 13 65ths. And like I said, the first step is to take a top one and a bottom one and see if I can reduce them by the same factor. Is there anything top and bottom I can reduce by the same factor? Yeah, how many times will 13 go into 65? So I can do 13 and 65 by the factor of 5. 13 goes into 13 how many times? Once. And 13 goes into 65 5 times. Now, when I look again, is there a top and a bottom that I can reduce by the same factor evenly? No. So when you say no, all you have to do is multiply 4 times 1 gives me 4, and 3 times 5 gives me 15. Check it again. Make sure that 4/15 cannot be reduced. What factor does 4 and 15 have in common to reduce evenly? What number will go into both 4 and 15 evenly? 1. So if it's 1, I'm done. This problem is done. I've reduced it as low as it can go. Here's another one. Is there a top and a bottom that I can reduce by the same factor? I can do the 2 9s and 8 and 16 by 8, right? 8 goes into 8 once. 8 goes into 16 twice. 9 goes into 9 once. And 9 goes into 9 once. So that leaves me with 1 over 2. Can I reduce 1 over 2? No. If I have 1, I already know I'm done, right? So let's actually look at how we're supposed to multiply fractions. When you multiply fractions, the first thing you need to do is any whole number or mixed number needs to become improper. Step 2, cancel if you can. Try to make the multiplication as low as you can. Step 3, multiply the numerators. Then step 4, multiply the denominators. And always check your answer to see if it can be reduced further, because you might have forgotten one, okay? So those are the steps, and I think I already listed these steps for you guys on your packet. I think, oh, okay, it's on page 4 in your packet. But you'll notice on page 2 and 3, we did some practice with mixed numbers and improper fractions before we started multiplying. Now, what does the word of mean? When you have a fraction that does not have a unit attached to it, let's say if it said 3/4 pounds or 3/4 ounces, that has a unit attached to it. But anytime you have just a fraction with no unit attached to it and the word of, it means that you're multiplying. So we want to replace of with the multiplication sign because we don't have any units here. What was the first step? The first step says that if you have any whole numbers or any mixed numbers, you need to make them improper. What do I have here? I have a proper fraction, and what's this? This is a mixed number. I need to change this to an improper fraction. How do I do that? So take the denominator, multiply it by the whole number. If I do that, I get 6. Then take that product and add it to the numerator, which gives me 7. Keep the same denominator, which is 6. Now this process is written for you on page 2 with a bunch of practice. Take the denominator, multiply it by the whole number, take the product and add it to the numerator, keep the same denominator. So the improper fraction for 1 and 1/6 is 7/6. Now I can multiply. Now, step 2 said that I need to cancel. Is there something I can cancel top and bottom by the same factor? The 3 and the 6. By what factor? By 3. So 3 will go into 3 once, and 3 will go into 6 twice. Is there another situation where I could cancel? No. So 1 times 7 is 7, and 5 times 2 is 10. Now, you still need to check that 7/10 is reduced as low as it can go. Is there a number that will go into both 7 and 10 evenly? Only one, so that means I'm done. Only one will work, and that means that this is low as it can go. What should I do first in this problem? Okay. And what is the improper fraction for 6 and 3/4? 4 times 6 is 24, plus 3 is 27. Keep the same denominator, which is 4. So 27/4. You keep the same denominator. I'm going to just rewrite it. Can I cancel? By what factor? By 9. 9 goes into 9 once, and 9 goes into 27 3 times. Can I cancel anything else top and bottom by the same factor? So what's 5 times 3? And 1 times 4 is 4. Can I leave my answer as 15/4? I have to simplify it. How do I do that? Divide. Now, if you go to page 3, I have given you practice on what to do with an improper fraction that needs to be simplified. When you give your final answer in your multiplication and your division problems, they cannot be improper fractions. They have to be mixed numbers or proper fractions that are reduced to lowest terms. So how do I do that? How do I make this simplified? Yeah, isn't this 15 divided by 4? Remember, one of the uses of fractions is division. So 15 divided by 4, 4 will go into 15 3 times. That leaves me with a 3. So what happens is the remainder here becomes my new numerator. And I keep the same denominator. So my mixed number is 3 3/4, and that is the answer. Can I reduce 3/4? No, I can't. 3 is a prime number, so as soon as you get a prime number, you pretty much know you're done. Okay? You try this one. What's the first step? Make it an improper fraction. That mixed number must become improper. All right, and what did you get? Okay, this is going to become 39 over 7. And then I was not able to reduce anything, right? So I had to take 1 times 39 is 39, and I had to take 4 times 7 is 28 because I couldn't reduce anything. I couldn't cancel. So I have to make the 39 over 28 an improper, a mixed number because it's already improper. It goes in 1 time, and I have 11 left over for my remainder, and I keep the same denominator. So 1 and 11 over 28 should be your answer. This one I couldn't cancel at all. And sometimes you're going to have some fractions and some problems where you don't reduce at all. Try this one. Five and 2/5. What did you get for the mixed number when you changed it to improper? Over 4. 27 over 4. Now, can I reduce that? Well, the 4s will cross out, right? Yeah, if I rewrote it, it might be clearer. But see, the 4s can cross out top and bottom. So that leaves me with 27 over 5. And 27 over 5 will give, what'd you say, 5 and 2/5? Yeah. When you divide it, you're going to get 5 and 2/5. Okay. What did you do wrong, Jacob?
Oh, the denominator used for 27 and 4 was 7, and I added
No. Keep the same one as you got when you had your mixed number. Keep the same denominator.
Well,
27 over 4.
by 7.
Oh, yeah. You can't reduce those. Yeah. You can only do 4 and 4. Yeah, you can only do 4 and 4. Okay? All right, try this one. You got a whole number? Wow, cool. What was your improper fraction here? 28 over 9. You didn't get 28 over 9?
Hold on.
Are you okay? So this is what you should have so far. 4 7s times 28 over 9. Can you cancel? Hello? Can you cancel? That's right. 7 and 28. Yeah, by 7. So 7 goes into 7 once, and 7 goes into 28 4 times. So you did get 16, but that was on top.
I mistake my 9 for a 1.
Oh, okay. So the 9 is still there.
Still there.
Yeah, so I'm not going to get a whole number here. So now I've got it reduced all the way down to 16 over 9, but I am not finished. Because this is an improper fraction, I need to simplify it and make it a mixed number. You're supposed to multiply and simplify. How do I make this a mixed number?
28 divided by 9.
You mean 16 divided by 9?
My God.
Are you okay, Curtis? Okay. So how many times will 9 go into 16?
Once.
And what's left over?
5.
5. You got 5? I got 7.
7.
Okay. Are you just doing it in your head?
No, I was thinking 9 plus 5 is 16.
No, 16 minus 7 gives me 9. Okay. So you should have 7 left over. 16 minus 9 is 7. So you'll have 7 for your remainder. That becomes your new numerator. And then you have 9. And I can't reduce 7 over 9, right? Because 7's prime, I'm done. Okay? All right, I got one more here. That's multiplying. Then we'll do division. Tell me what you get. Okay? What was your improper fraction here? I got 25, right? 25 over 4. Then I can cancel a lot here. I can cancel 5 and 25, and I can cancel 2 and 4. So I can do 2 cancellations here. 5 goes into 25 5 times. 5 goes into 5 once, so that's one of them. Then I got 2 goes into 4 2 times, and 2 goes into 2 once. That leaves me with 5 over 2, which is clearly 2.5. You can do that kind of in your head. So any questions on that process at all? The cancellation really helps you get the numbers down to something manageable. You don't want big, gigantic numbers that you have to divide. You want to cancel if you can. Do that step 2. I think that was the last one, you guys. Yeah. What would this be? I don't need to do anything improper. So what would that be? What can I cancel?
4 and 8.
The 4 and the 8. I take a top and a bottom by the same factor. So 4 will go into both 4 and 8. So 4 goes into 4, and 4 goes into 8. So can I cancel anything else? No. So what would that give me as my answer? 3/10. Okay. Don't you guys like them when they're easy like this? You don't even have to make anything improper. Ooh. What should I do here? I know these numbers scare you, but you can cross cancel both of these. Because 19 goes into 57 how many times? 3. And 51 goes into 102 twice. So I didn't make them too bad, right? Well, hey, if I had $102 to give you right now, you would be liking that number. So don't be getting no attitude about the numbers being big, okay? It's all relative. If you're getting it as a gift, you want the number as big as possible, right? And for 19, 19 goes into 57 3 times and 1 time here.
We have a whole number 6.
Hey. Don't you like problems like that? Your answer is 6. So that problem was not that bad once you thought about what to cancel. This is why canceling is great. It gets these numbers down to something very manageable. So take the time to cancel, okay? Try this one. This one's a little bit more manageable for you guys. Remember, take one top one and one bottom one at a time and reduce them. Because we could reduce everywhere around here. Okay? Just take one top and one bottom, whichever one you want, and reduce them. And then you guys tell me what you get. Okay, I'll call you. There's so many cancellations I could do. I could do 35 and 40. I could do 24 and 18. I could do 40 and 18. What'd you come up with? 1 and 1/7? Okay, Ronald. You go by Ron or Ronald? Ron? Okay. You don't like Ronald? You just like Ron?
I go by Ron.
That's just how you go? Okay. So you said you got 1 and what? 1 and 1/7. Okay. Anybody else? Y'all get the same answer? You guys still working? Okay, Ron, what did you cancel? So did you do 35 and 40?
Yep.
So 5? Oh, wait, let me do 24. I must have did 24 and 18. 24 and 18, we could do both of those by 3 or 6, okay? So 6 goes into 24 4 times, 6 goes into 18 3 times. Then 5 goes into 40 8 times, and 5 goes into 35 7 times. And it doesn't look like we can cancel anything else. You get 32 over 21.
1 and 11/21 is what I got.
You got what?
1 and 11/21.
Yeah, I'm going to get 11. How'd you get 7, Ron? What step? On the when you reduced it? Okay. But you see where your mistake is? Okay. So the one thing to keep in mind, because with that 24 and 18, we could have used a whole bunch of different factors. We could have used 2. We could have used 3. But the greatest common factor between those two is 6. So that's the one I used. But even if you use 2 initially, then go back and use 3. We keep on reducing till you can't reduce anymore. But that was a good example of how you can, you need to be careful when you're canceling. Try to get them all the way down. So 1 and 11 over 21 is what I got. What's this one? You guys can do this in your head. No. 3 over 11. Because we're going to cancel the 8s. Now, some people don't like to listen to me. And that's okay. If you decide that you're going to just multiply and then reduce because you can handle the big numbers, then do so. Just make sure that you reduce properly. And when we reduce, we get 3 over 11. But I like my way where you just cross those out and you already know it's 3 11ths. Okay? But you can do it the longer way where you multiply them and then divide. That's okay. You just need to make sure that you reduce properly. What about here? I don't care which way you guys do it. Just do it and tell me what you get.
30 over 8.
Well, if you get 30 over 8, don't you need to reduce it? But let's say I did it the long way. What did you get? Yeah, because you're going to have to reduce. So if you did not cancel, you'd end up with 3 and 18 over 24. But 18 over 24 can be reduced by 6. And your final answer better be 3 3/4 if you do it the long way. Now, I'm just doing it the long way here without cancellation to show you that you can do it without cancellation. I just don't recommend it. You will have a higher propensity to make a mistake when you have bigger numbers to deal with. But you don't have to listen to me. Let's talk about division. What's a reciprocal? If I have 1 over 2, what's the reciprocal? 2 over 1. If I have 9 over 10, what's the reciprocal? 10 over 9. So what's the reciprocal? The inverse. I want you guys to use the right math word. Inverse, okay? A reciprocal is an inverse, okay? You're just flipping the fraction around. That's all you're doing, okay? Now, it is easier for people to multiply than divide. It is easier for people to add than subtract. So the reason I teach the reciprocal for dividing is because you don't have all these crazy complex fractions where you're trying to do your subtraction. It's just kind of crazy to do it that long way. But if you will take the reciprocal and you will use the strategy that I teach you, division of fractions is a piece of cake, because all you're going to do is multiply by the inverse or multiply by the reciprocal. Or, as I like to teach it, keep, switch, flip. I want everybody to say that. Keep, switch, flip. This is only for division. Division of fractions. If you remember the keep, switch, and flip, you're not going to go wrong. Okay? Here we go. Rules. Change any whole number or mixed number to an improper fraction. Hey, didn't we hear that on the multiplying side? Same step. Then, keep, switch, flip. This is a strategy I'm going to teach you. Cancel if you can. Multiply the numerators and denominators and make sure everything has been reduced and simplified. Now, when in the keep, switch, and flip, you got to know that the reciprocal is the inverse of the fraction. So 5 steps, just like 5 steps for multiplying. Okay? Change any whole numbers and mixed numbers to improper fractions, just like we do when we multiply. Keep, switch, and flip strategy is step 2. Cancel if you can is step 3. Multiply your numerator, denominator is step 4. And 5, just make sure it's simplified.
So the reciprocal is an inverse of a fraction only?
Yeah.
Okay.
Now, Jacob, when you say that, remember, if I have the whole number 8, what is the improper fraction for the whole number 8? Yes, it is. I can write an improper. It'll be 8 over 1. So what's the inverse of 8? 1 over 8. And that goes for any whole number. So if I had the whole number 10, it would be 1 over 10 for the reciprocal. If I had the whole number 99, the reciprocal for 99 is 1 over 99. Okay? So I want to clarify your question, because I would need to make that whole number improper and then do the inverse. Okay? Because the first step in multiplying and dividing fractions is to make any whole numbers and any mixed numbers improper. Then you flip. Only the second fraction. Do not flip the first fraction, because it's keep, which means keep the first fraction. Switch, which means switch the multiplication, switch the division to multiplication, and then flip, only the second fraction. Write each mixed number and whole number as an improper fraction. That's your first step. So what will 13 become? 13 over 1. What will 4 1/2 become? 9 over 2. 13 over 1. Remember, I don't care what the whole number is. You can make it improper. And it helps you balance out your equation too, or your expression, whatever you're working on. Now, remember, if I have a mixed number, I need to take the denominator and multiply it by the whole number. In this case, it would be 8. I need to add the numerator to make it an improper fraction. Keep the same denominator. So don't forget what we just learned. I show you how to do this on page 2 of your packet today. Okay, on page 2. Don't forget it. Then number 2, find the reciprocal of the second fraction. Numerator and denominator are going to switch positions. That's all you're doing is flipping them over, taking the inverse, making a reciprocal. It is much easier to multiply than try to divide. That's why I'm doing this, okay? It's just so much easier. What's the reciprocal of 4/5? 5/4. What's the reciprocal of 9/2? Okay. And what is the reciprocal of 13/1? Okay, good. So you guys got it. All right, let's look at the process. Here we go. I have 5 divided by 2/9. What's the first step? That 5 becomes 5 over what? Thank you. That's the first step. My problem changes to 5 over 1 divided by 2 over 9. Then I'm going to keep the first fraction. Switch the operation to multiplication and flip the second fraction. So what is this going to become? 9/2. Now, I cannot do any cancellation or multiplication until I do this keep, switch, and flip. I have to do the keep, switch, and flip before I do anything else. Any questions on what keep, switch, and flip means? Keep the first fraction the way that it looks. Change the division to multiplication. And flip the second fraction. Number 2. Can I cancel anything? No, not on this one. So I get 45 over 2. Can I leave my answer as 45 over 2? What is the actual answer? 22.5, because I have to split 45.5. Okay? Keep, switch, flip. Only for division of fractions. Let's try another one. What do I have here? I got 2 mixed numbers that both need to become improper. What's the improper fraction for 3 3/4? And what's the improper fraction for 1.5? 3/2. You guys will know that by heart. So 15 over 4 divided by 3/2. I just rewrote it so that I have improper fractions, okay? Now I'm going to keep, switch, and flip. What's my first fraction? 15 over 4. Keep it. Switch the operation to multiplication. Then what do I do? 2 over 3. Flip that second one. Can I cancel? What? By what factor? Okay. By 2. Okay. So 2 goes into 4 2 times. 2 goes into 2 once. So that's one cancellation I can do. Then 3 goes into 15 5 times, and 3 goes into 3 once. That's the second one I can do. Can I cancel anything else? Nope. So I get 5 over 2. Can I leave my answer as 5 over 2? So what is that? 2.5. Divide 2 into 5, and you're going to get 2.5. Any questions on this one where I had 2 mixed numbers? Nope. Okay. All right, your turn. Do these 2 problems, and I'd like 2 people to come up and put their answer on the board. The first one's easy.
It would have been 7 on the second one.
Nope, it better be 24.
Yeah.
Oh, okay, you got a 7 in your head. Better be 24.
That's my
If you were Jorge writing a fancy 4, I could understand, because he likes to write fancy numbers. Okay, now I know the top one's 24. The bottom one I'm going to have to do. You got 7? That was a whole number too? Oh yeah, that's what I came up with. Okay, so we start with 12 and a half times 2 over 1, because we had to flip this one. And when you multiply it, you get 24 over 1, so that's 24. Now here, this mixed number becomes an improper fraction of 7 over 4. Here we go. And it's still divided by 1/4. Then we keep, switch, and flip. The 1/4 becomes 4 over 1. And these 4s will cancel. That leaves me with 7 over 1, which is equal to 7. So I started you guys out pretty easy when you got whole numbers, right? Are there any questions about how we got 24, or any questions about how we got 7 on the second one? Okay, here's 2 more. Do those 2, and then I need answers on the board. Oh, let me erase these original answers so you guys can type right up the correct one. Thank you, Jacob. Even though Jacob put an answer up on the board, you guys still need to do the problem and verify it. Make sure that you come up with the same answer. If not, let's debate it. Is that a 4, Jorge?
Yeah.
Okay, 4 3/8 is what you got for the second one? Is that right, you guys?
That's what I got.
Okay. So on the first one, we're going to have 4/5 times 3 over 2. And we could have canceled it. I got 1 and 1/5. That's what he has. And then on this one, we're going to get 5 over 2 divided by 4/7. 5 over 2 divided by 4/7, which is keep, switch, and flip. That becomes 35 over 8. And when you divide it, you're going to get 4 3/8. So those answers look good. Any questions on those 2? No questions? All right, in your packet, are there any questions yet? Okay, when you guys are working on your study guide, let me know if you get stuck on one of these. But the way you get good at this is to practice. So get those study guides done. Let me stop the video.